Space, the final frontier.
Fallacies are very much like the laws of inference in that they are also based on other types of arguments. So to refresh ourselves, an argument is the process of using statements known to be true to justify the truth value of a new statement. So given a premise, we make a conclusion. Now, in all of the laws of inference we've talked about, the argument arrives at a conclusion which is always true. This is referred to as a valid argument. What we're going to look at today in this video is an argument which arrives at a conclusion which is not always true, and this is what's known as an invalid argument. Now, there are three special types of invalid arguments that we're going to talk about, and these are the fallacies, the invalid arguments that are made so often that they get special names. So first, say you're presented with an argument with the premise P or Q, and the second premise is P, and the conclusion being made is not Q. So my question to you, is that a valid or an invalid argument? So take a moment to think about that for yourself.
That's one that would pose an extremely complex problem in logic, Mr. Spock.
It turns out that this is actually going to be an invalid argument. So this is going to be an invalid argument. And this one in particular is the fallacy of disjunction. Now, how do I actually verify that this is an invalid argument? We can use a truth table. So to set up my truth table, the first thing I'm going to do is include all of the statements that I see in the argument. So I see a P, I see a Q, I see P or Q, and I see a not Q. So I have all those statements written here. Now the P's and Q's are really easy. We set those up with every possible combination of their truth values. For not Q, it's actually very convenient. If I look at the statement Q, what's going to happen is not Q will have all the opposite truth values, so all of the opposite truth values of that. When I look at P or Q, I'm going to look at these two columns here. And I'm going to look for whether this or this is true. That's my rule for determining the truth value for this. So is P or Q true? Yes, in this case. Is P or Q true? Well, P is true, so this will be true. Is this or this true? Yes. And is this or this true? Nope, they're both false. So it'll be false in that situation. Once I've determined the truth values for all of these statements in the argument, I'm going to then look at what is the premise. Well, I have two statements that make up the premise, and both will have to be true. So I'm looking at P and P or Q. So these two statements combined. So to determine the truth value of that, I'm going to look at the two columns in which those two values show up. Okay, so now in order for this combined statement to be true, both of these will have to be true together. So true and true is true. True and true is true. False and true is false. And false is false. So I've determined the truth values of those two statements, of that combined premise statement. So this represented the premise. The next thing I'm going to ask myself is, does the conclusion follow from the premise? So if the premise occurs, then does the conclusion follow? So I can write that like this. If the premise, then the conclusion. I'm going to determine the truth value of that in every possible situation I have listed here. So to determine that, I'm going to look at the column I just wrote up for the premise and the column for not Q that we made earlier. So looking at these, it's from this to this. So true implies false. That's my broken promise. I promised that if this hypothesis, then this conclusion. Well, the hypothesis occurred and the conclusion did not, so this would be false. Immediately, I can stop my process. I know that there is at least one possible situation in which this conclusion does not follow from the premise. Now you can continue testing the truth values for the rest of them, and it actually turns out that they're all going to be true in the remaining situations. But because of the fact that I have this one false statement, this argument is not always going to be true. Since it's not a tautology, it's an invalid argument. There are some cases where the conclusion doesn't follow from the hypothesis. From this premise, this conclusion sometimes does not follow. That's what makes it an invalid argument. Anytime you end up with at least one situation in which it's false, it's an invalid argument. Now there are three fallacies, which are extremely common in valid arguments. One is the fallacy of disjunction, which we just looked at, and the other two are the fallacy of the converse and the fallacy of the inverse. Recall that when we looked at conditional statements like P implies Q, the inverse and the converse were not logically equivalent, meaning that they did not share all the same truth values, and that's what these arguments are kind of using. It's kind of trying to use the converse statement in law of detachment to make this conclusion, and this one the inverse statement in law of detachment. But since those converse and inverse statements are not logically equivalent to the original, those are invalid arguments, and they are, in fact, fallacies.
To me, it is quite illogical